Hello, welcome. Tonight, we will explore the planets of our solar system together, slowly, in detail, calmly. Settle comfortably into your place. You can close your eyes or keep them open. It doesn't matter. Just listen and let your mind wander. Now, starting from our sun, we will visit each planet one by one. We will tell their stories, their characteristics, quietly. If you're ready, let's begin. Mercury. General introduction. The smallest planet in the solar system, Mercury, the closest to the Sun and the fastest moving. Mercury's diameter is only 4,879 kilometers. This is approximately 40% of Earth's diameter. A small planet, but an interesting planet. Orbital characteristics. Mercury orbits the Sun once every 88 days. Measured in Earth days, just 88 days. This is the shortest year in the solar system. But here's something interesting. Mercury rotates very slowly on its axis. It takes 59 Earth days for one complete rotation. This means a day on Mercury lasts almost 2 Mercury years. Simply put, on Mercury, the Sun rises, moves very slowly across the sky, and sets 176 Earth days later. A long day, a very long day. Temperature and atmosphere. Mercury has almost no atmosphere, a very thin layer. Scientists call it an exosphere. It contains atoms of sodium, potassium, hydrogen, and helium, but it's not dense enough to be called an atmosphere. Because there's no atmosphere, temperature varies greatly. On the side facing the Sun, temperature reaches up to 430 degrees Celsius. Lead can melt at this temperature, tin can melt. But on the night side, the side where sunlight doesn't reach, temperature drops to minus 180 degrees Celsius. Such a large temperature difference on one planet is rarely seen. Surface features. Mercury's surface is very similar to the Moon's, covered with craters and old, silent surface. Its largest crater is called the Caloris Basin. Its diameter is 1,550 kilometers, formed by a very large impact billions of years ago. Mercury's surface also has long, deep cliffs. These are called rupes. They formed as the planet cooled and contracted. Just like an aging apple wrinkles, Mercury has wrinkled over time. Name and mythology. Mercury takes its name from the messenger god in Roman mythology. Mercury, wearing winged sandals, a fast-moving god. The ancient Romans saw this planet moving very quickly across the sky, and they gave it the name of the swift messenger god, an appropriate name because Mercury truly does move very fast. Discovery history. Mercury is one of the 5 planets visible to the naked eye. Therefore, it has been known throughout human history. The ancient Sumerians knew it. The Babylonians knew it. The ancient Greeks and Egyptians too. In terms of modern discovery, only 2 spacecraft have studied Mercury up close. The first was Mariner 10. It visited Mercury 3 times in 1974 and 1975. The second craft was Messenger. It entered Mercury's orbit in 2011 and operated until 2015. It took thousands of photographs, mapped 100% of the surface. Core and magnetic field. Mercury has a large iron core. The core is approximately 75% of the planet's total volume. This ratio is very high compared to other planets. Because of this large core, Mercury has a magnetic field. About 1% as strong as Earth's, but it still exists. This magnetic field interacts with the solar wind and creates a small magnetosphere around Mercury, like a protective shield, but a weak shield. Venus. General introduction. Now we move to the second planet, Venus, the hottest planet in the solar system, and the planet known as Earth's twin sister. Venus's diameter is 12,104 kilometers, very close to Earth's, only 5% smaller. Its mass is also 81% of Earth's. That's why it's called the twin planet. Atmosphere, toxic and dense. But the similarities end there, because Venus's atmosphere is completely different. Venus's atmosphere is very dense. The pressure at the surface is 92 times the pressure at Earth's sea level, like being 900 meters deep in the ocean, crushing pressure. 96% of the atmosphere is carbon dioxide. The rest is mostly nitrogen and clouds, sulfuric acid clouds. Yes, acid rain clouds. This dense carbon dioxide atmosphere creates a powerful greenhouse effect. Heat from the sun enters but cannot escape. It's trapped. Temperature like hell. The result? Venus is the hottest planet in the solar system. Average surface temperature is 465 degrees Celsius. Mercury is closer to the sun, but Venus is hotter. Because Mercury has no atmosphere, it cannot retain heat, but Venus has trapped the heat. At this temperature, lead can melt, tin can melt, zinc can melt. Not like inside an oven, like inside a blast furnace. And this temperature is the same day and night, the same at the poles and at the equator. The atmosphere distributes heat so well, everywhere is the same hell. Rotation, backward and slow. Venus's rotation is very interesting. It has two characteristics different from other planets. First, Venus rotates backwards. While most planets rotate counterclockwise, Venus rotates clockwise. This is called retrograde rotation. Second, it rotates very slowly. One complete rotation takes 243 Earth days. This is longer than Venus's orbital period around the Sun. Yes, a day on Venus is longer than a year. Scientists don't know exactly why it rotates backwards and slowly. Perhaps there was a large impact in the planet's youth. Perhaps tidal forces were influential. It's not certain, just theories. Surface. Volcanic and young. Venus's surface was unknown for a long time because thick clouds completely hide the surface. But radar can penetrate clouds. In the 1990s, the Magellan spacecraft mapped Venus's surface using radar and discovered a surprising surface. The surface is covered with volcanic rocks. There are thousands of volcanoes. Some are very large, hundreds of kilometers wide. Mont Mons is one of Venus's highest volcanoes, approximately 8 kilometers high, can compete with Earth's highest volcanoes. Scientists think Venus's surface is relatively young, perhaps 300 to 500 million years old. This is considered young for a billion-years-old planet. Why so young? Because Venus probably had a global volcanic resurfacing. The entire planet was covered with lava. The old surface disappeared. A new surface formed.
Clouds and winds. Venus's clouds are in constant motion, very rapid motion. In the upper layers of the atmosphere, winds blow at 360 kilometers per hour. This is called superrotation, much faster than the planet's own rotation. These clouds form V-shaped patterns. Seen from space, yellow-white clouds drawing V-shapes as they rotate continuously. In recent years, scientists claim to have found phosphine gas in Venus's clouds. Phosphine is a gas that can be produced by living organisms. Does this mean there might be life on Venus? Not certain. It's a controversial topic, but an interesting possibility. Name and mythology. Venus bears the name of the Roman goddess of love and beauty. Because it's the brightest planet in the sky, it was seen as the most beautiful planet. Morning star, evening star. Ancient people called Venus this. It shines from the east in the first light of morning, shines from the west in the first darkness of evening. The ancient Maya gave special importance to Venus. They tracked the Venus cycle in their calendars. They looked at Venus's position to start wars. Discovery history. Many spacecraft have visited Venus. The Soviet Union's Venera program sent many probes in the 1960s and 70s. Venera 7 became the first spacecraft to land on Venus's surface in 1970. It could only operate for 23 minutes because the temperature and pressure were so high, the electronics broke down very quickly. Later Venera probes lasted longer. They took photographs, analyzed the surface. They gave scientists the first information about Venus's hell-like surface. The Magellan spacecraft operated in Venus's orbit from 1990 to 1994. It created radar maps. It mapped 98% of Venus's surface. Earth. General introduction. The third planet, our home, Earth. Earth's diameter is 12,742 kilometers. Its average distance from the Sun is 150 million kilometers. This distance is called an astronomical unit. It's used to measure the distances of other planets. The planet of life. Earth is the only planet we know of that harbors life. Millions of species, trillions of living beings, all on this blue planet. The conditions needed for life have come together here: liquid water, suitable temperature, protective atmosphere, and magnetic field. Are these conditions a coincidence or some kind of cosmic luck? We don't know, but what we do know is it's a very rare combination. Atmosphere, breathable air. Earth's atmosphere is mostly nitrogen, 78% nitrogen, 21% oxygen. The rest is argon, carbon dioxide, and other gases. This oxygen was produced by photosynthesizing organisms. Over billions of years, plants, algae, and bacteria produced oxygen. They changed the atmosphere. The early Earth's atmosphere had no oxygen. It was a toxic atmosphere. But life changed the atmosphere, made it breathable. The atmosphere also protects us. It filters harmful radiation from the sun. The ozone layer absorbs ultraviolet rays, burns meteors, balances temperature. Hydrosphere, water world. Approximately 71% of Earth's surface is covered with water: oceans, seas, lakes, rivers. The total amount of water is approximately 1.4 billion cubic kilometers. The vast majority of this is saltwater, oceans. Only 3% is freshwater, and most of the freshwater is locked in glaciers and underground. The water cycle is in constant motion: evaporation, condensation, precipitation, runoff. The cycle continues. There's never a moment it stops. This water is critical for life. Every living thing we know needs water. Without water, there is no life. Lithosphere, solid crust. Earth's outermost layer is the lithosphere, consists of solid rocks, continents, and ocean floors. The lithosphere is not a single piece. It's divided into plates, tectonic plates. These plates move very slowly, a few centimeters per year, but they move constantly. Plates collide, mountains form. The Himalayas formed this way. The Indian plate is colliding with the Eurasian plate. Mountains are rising. Plates move apart, new ocean floor forms. The Atlantic Ocean is expanding. The American continent is moving away from Europe. Plates slide under each other, volcanoes form. The Ring of Fire, volcanoes and earthquakes surrounding the Pacific. Magnetic field, invisible shield. Earth has a strong magnetic field. Movements in the liquid iron layer of the core create this field. It's called the dynamo effect. This magnetic field protects us. It deflects the solar wind, pushes away charged particles. If it didn't exist, the solar wind could strip away the atmosphere. At the poles, the magnetic field interacts with the atmosphere. Northern lights form, aurora borealis. Green, purple, red curtains. They dance in the sky. Moon, faithful satellite. Earth has one satellite, the Moon. Its diameter is 3,474 kilometers, about 1/4 of Earth's diameter. The Moon is relatively large compared to other planets' satellites. The planet-to-satellite size ratio is very high. How do scientists think the Moon formed? The most common theory is the giant impact theory. In the early period of Earth's formation, a giant impact object collided. They've named this object the Theia. As a result of the collision, tremendous amounts of material were scattered into space. This material came together in Earth's orbit, and the Moon formed. The Moon affects Earth. It creates tides, pulls the oceans, slows Earth's rotation, stabilizes its axis. Without the Moon, Earth's tilt would be very variable. Seasons would be chaotic. Maybe life couldn't develop. Seasons, tilted axis. Earth's rotation axis is tilted 23.5 degrees relative to its orbital plane. This tilt creates the seasons. In summer months, the northern hemisphere tilts towards the sun. Sunlight comes directly. Days are long, warm season. In winter months, the northern hemisphere is away from the sun. Sunlight comes at an angle. Days are short, cold season. In the southern hemisphere, it's exactly opposite. When it's summer in the north, it's winter in the south, and vice versa. This seasonal change shapes life. Plants' growth cycles, animals' migration routes, all are adjusted according to the seasons. Climate zones. Earth has different climate zones. Tropical regions, always warm. Sunlight comes directly year-round. Polar regions are always cold. Sunlight comes at a very steep angle. In winter months, there's no daylight at all. Middle latitudes, temperate climates. 4 seasons are distinct: spring, summer, autumn, winter. Each climate zone harbors different life forms. Tropical rainforests have the richest biodiversity. Poles have the most difficult living conditions, but there's still life. Human age, Anthropocene. In the last few thousand years, and especially in the last 2 centuries, humans have significantly changed Earth. They cut forests, built cities, changed river flows, released carbon dioxide into the atmosphere. Some scientists say we're now in a new geological epoch, the Anthropocene, the human age. Because human impact is so large, it will appear in the geologic record. Climate is changing, temperatures are rising, glaciers are melting, sea levels are rising, species are going extinct. But at the same time, humans are also increasing their efforts to protect Earth. Renewable energy, protected areas, sustainable living. Earth's future depends on human choices. Mars. The 4th planet, the red planet, Mars. Mars's diameter is 6,779 kilometers, roughly half of Earth's. Its mass is also 1/10 of Earth's. A small planet, a reddish planet. Red color, iron oxide. Why is Mars red? Because its surface is covered with iron oxide. In other words, rust. The entire planet is like it's rusted. Billions of years ago, Mars had abundant iron. There was water, there was oxygen. Iron reacted with oxygen. Iron oxide formed, rust. This rust mixed into the soil, mixed into the rocks, covered the dust. Everything turned red. Seen from the sky, Mars looks like a red dot. Ancient people associated this red color with blood. They called it the color of the war god. Atmosphere, thin and cold. Mars's atmosphere is very thin. The pressure at the surface is only 0.6% of the pressure at Earth's sea level, almost like a vacuum. 95% of the atmosphere is carbon dioxide. There's also a small amount of nitrogen and argon. There's almost no oxygen. This thin atmosphere cannot retain heat. Mars is very cold. Average temperature is -63 degrees Celsius. At the equator, on summer days at noon, the temperature can rise to 20 degrees Celsius, a pleasant temperature. But at night, it drops to -73 degrees, a tremendous difference. At the poles, temperature can drop to -125 degrees. Carbon dioxide freezes, dry ice forms. Surface, from deserts to mountains. Mars's surface is diverse. Deserts, mountains, canyons, craters. Olympus Mons is the largest volcano in the solar system. Its height is 21 kilometers. Its base width is 600 kilometers. A giant mountain, a giant volcano. Earth's highest mountain, Everest, is only 8.8 kilometers. Olympus Mons is 2.5 times that. Valles Marineris is a tremendous canyon system. Its length is 4,000 kilometers. Its width reaches 200 kilometers in places. Its depth is 7 kilometers. America's Grand Canyon seems small next to this. Valles Marineris is 10 times the length of the Grand Canyon. The northern hemisphere is flat and low. The southern hemisphere is rugged and high, covered with craters, an ancient surface. Water, past and present. There is no liquid water on Mars today. The atmosphere is too thin, the pressure is too low. Water boils and evaporates immediately. But there was water in the past. Scientists are certain of this because there's evidence. Dry riverbeds, valleys carved by water, traces left by sediments. These show that liquid water once flowed on Mars. Perhaps there were oceans that filled the low areas of the northern hemisphere. Perhaps it rained. Perhaps the climate was warm. What happened? Mars lost its atmosphere. Its magnetic field weakened. The solar wind stripped away the atmosphere. Water evaporated, escaped into space. Today, water exists as ice, polar ice caps, underground ice, a mixture of dry ice and water ice. In 2018, scientists discovered a liquid lake beneath Mars's south pole. Under the glaciers, melted salty water. Could there be life? Maybe. Satellites, Phobos and Deimos. Mars has two small satellites, Phobos and Deimos, fear and terror, Greek names. Phobos, its diameter is only 22 kilometers, potato-shaped. Its surface is covered with craters. It orbits very close to Mars. Phobos is so close to Mars, it's slowly spiraling down. It approaches by 1 meter every 100 years. In about 50 million years, it will crash into Mars or break apart. Deimos is smaller. Its diameter is 12 kilometers. In a more distant orbit, it moves more slowly. We don't know the origin of these satellites for certain. Perhaps they're captured asteroids. Perhaps they formed from a giant impact on Mars. Name and mythology. Mars bears the name of the Roman god of war. In Greek mythology, Ares. the god of violence and bloodshed. Its red color was associated with war and blood. In ancient cultures, Mars's position was seen as a harbinger of war and disaster. The ancient Babylonians called Mars Nergal, god of the underworld, god of death and disease. Every culture attributed special meaning to Mars, but all were influenced by its red color. Discovery, world of robots. Mars is the most explored planet outside of Earth. Dozens of spacecraft have been sent to Mars: orbital surveyors, landing modules, rovers. Mariner 4 became the first craft to image Mars up close in 1965. It took only 21 photographs, but these were the first close photographs. Viking 1 and Viking 2 landed on Mars's surface in 1976, the first successful landings. They took photographs, analyzed soil samples. Later, Pathfinder, Spirit, Opportunity, Curiosity, Perseverance, each one explored Mars more. Opportunity operated for 15 years, traveled 45 kilometers, took thousands of photographs. Communication was lost after a dust storm in 2018. Perseverance is currently working on Mars, in Jezero Crater, an ancient lakebed, looking for signs of life. Future, humans on Mars. Mars is seen as the next target for human space exploration. Many space agencies and companies are making plans to send humans to Mars. NASA plans to send astronauts in the 2030s, but the challenges are many: long journey, radiation, thin atmosphere, cold climate, resource scarcity. Living on Mars won't be easy. Underground habitats, greenhouse systems, water extraction technologies will be needed. But perhaps one day, Mars is humanity's second home. Perhaps one day, Mars turns green again. Jupiter. General introduction. The fifth planet, king of giants, Jupiter. Jupiter is the largest planet in the solar system. Its diameter is 139,820 kilometers, 11 times that of Earth. Its mass is 2.5 times the combined mass of all other planets in the solar system. A giant planet, a gas giant. Structure, gas and liquid. Jupiter has no solid surface. It's entirely made of gas and liquid. The atmosphere is mostly hydrogen and helium, 90% hydrogen, 10% helium, just like the Sun. As you go down, pressure increases, gas condenses, becomes liquid. Deeper still, pressure is so high, hydrogen becomes metallic, metallic hydrogen. It conducts electricity, a state of matter that doesn't exist under normal conditions. At the very center, there may be a small solid core made of rocks and metals, but it's not certain.
Atmosphere and clouds. Jupiter's atmosphere is covered with colored bands: light-colored regions, dark-colored regions. Light regions, rising gases, called zones. Dark regions, descending gases, called belts. These bands extend in parallel lines. They form due to Jupiter's rapid rotation, the Coriolis effect. Clouds are made of ammonia crystals. There are also water crystals, ammonium hydrosulfide clouds too, each at different altitudes. Colors come from chemical compounds: phosphorus, sulfur, organic compounds. Sunlight and radiation change them, make them colorful. Great Red Spot. Jupiter's most famous feature, The Great Red Spot, a giant storm. This storm has been going on for at least 350 years, perhaps longer. It was first observed in 1665. Its size varies. Currently, it's approximately 16,000 kilometers wide, larger than Earth, but it's shrinking. It was bigger in the past. The storm's wind speed reaches 500 kilometers per hour, a tremendous hurricane, but in space. Why is it red? We don't know exactly. Perhaps chemical reactions, perhaps organic compounds, perhaps phosphorus. Why does it last so long? Because there's no solid surface on Jupiter, no friction to stop the storm. Energy loss is very small. Rapid rotation. Jupiter rotates very fast. One complete rotation takes only 10 hours, the fastest rotation in the solar system. Such rapid rotation flattens the planet. Jupiter is a slightly oblate sphere. Its equator bulges, its poles are flattened. Rapid rotation also creates a powerful magnetic field. Jupiter's magnetic field is the strongest in the solar system, 20,000 times stronger than Earth's. Magnetosphere and radiation. Jupiter's magnetosphere creates a massive magnetosphere. It pushes the solar wind millions of kilometers away. This magnetosphere traps charged particles. Radiation belts form, very intense radiation. Spacecraft near Jupiter are damaged by this radiation. Electronics can malfunction. That's why exploring Jupiter is difficult. At Jupiter's poles, auroras form, much larger and more powerful than Earth's. They're constantly active. Rings, thin and faint. Jupiter has rings, but they're not bright like Saturn's. They're thin and faint. There are 4 main ring regions. The innermost, the halo ring, thick and hazy. The main ring is the brightest, but still faint, made of microscopic dust particles. The gossamer rings are the outermost rings, 2 separate rings, very thin, almost invisible. These rings are probably made of dust kicked up by micrometeorites hitting Jupiter's moons. Satellites, tiny worlds. Jupiter has 95 known satellites, perhaps more. New ones are constantly being discovered. The 4 largest satellites are known as the Galilean satellites because they were discovered by Galileo Galilei in 1610. For the first time, objects orbiting a planet were seen. Io, the innermost Galilean satellite, diameter 3,643 kilometers, the most volcanically active body in the solar system. Hundreds of active volcanoes, lava erupts, the surface is constantly renewed. Io's volcanism comes from Jupiter's tidal forces. Jupiter's giant mass squeezes and pulls Io. Its interior heats up, melts, volcanoes erupt. Europa, the second satellite, diameter 3,122 kilometers, covered with an ice shell. Beneath the ice, a massive ocean, liquid water ocean, perhaps 100 kilometers deep. Could this ocean harbor life? Scientists are hopeful. In Earth's deep oceans, there's life without sunlight. Perhaps there is on Europa too. In the future, special missions to Europa are planned to drill through the ice, descend into the ocean, search for life. Ganymede, the third satellite, diameter 5,268 kilometers, the largest satellite in the solar system, even larger than Mercury. Ganymede has its own magnetic field, very rare for a satellite. Its surface is covered with ice, but beneath there's a rocky core, perhaps liquid water layers too. Callisto, the fourth satellite, diameter 4,821 kilometers, the outermost Galilean satellite. Callisto's surface is covered with craters, a very ancient surface. one of the most cratered surfaces in the solar system. Beneath, perhaps an underground ocean, like Europa, but deeper, more uncertain. Name and mythology. Jupiter bears the name of the king of the Roman gods. In Greek mythology, Zeus, god of thunder and lightning. The most powerful planet, the most powerful god. An appropriate name. Jupiter's satellites bear the names of Zeus's loves: Io, Europa, Ganymede, Callisto, all lovers or victims of Zeus. Discovery history. Jupiter is visible to the naked eye, so it's been known since ancient times. Galileo observed it with a telescope for the first time in 1610. He discovered its 4 large satellites. This discovery supported Copernicus's heliocentric theory. Modern exploration began with spacecraft. Pioneer 10 and 11 passed Jupiter in the 1970s, the first close photographs. Voyager 1 and 2 studied the Jupiter system in detail in 1979. Satellites were discovered, rings were discovered, atmospheric details were seen. The Galileo spacecraft operated in Jupiter's orbit from 1995 to 2003. Satellites were studied in detail. A probe was sent into Jupiter's atmosphere. The Juno spacecraft has been in Jupiter's orbit since 2016. It's studying the poles, researching internal structure, mapping the magnetic field.
Jupiter's importance. Protective giant. Jupiter plays an important role in the solar system. Its giant mass affects other bodies. It can capture asteroids and comets. It can change their orbits. It can prevent them from hitting the inner planets. Some scientists say if Jupiter didn't exist, many more meteorites would hit Earth. Jupiter acts as a shield, but at the same time, it can also send some bodies into the inner solar system, a two-way effect. In any case, Jupiter's presence has shaped the structure of the solar system. Saturn. General introduction. The 6th planet, Lord of the Rings, Saturn. Saturn is the 2nd largest planet in the solar system. Its diameter is 116,460 kilometers. Its mass is 95 times that of Earth, but its density is very low. Average density is less than water. Theoretically, if there were a large enough ocean, Saturn would float. Structure. Gas giant. Saturn is also a gas giant like Jupiter. It has no solid surface. The atmosphere is mostly hydrogen and helium. Inside, as pressure increases, it liquefies. Deeper still, metallic hydrogen. At the center, there may be a small rocky icy core, several times larger than Earth, but it's not certain. Rings. Magnificent structure. Saturn's rings are among the most beautiful structures in the solar system. Magnificent, complex, mesmerizing. The rings consist of thousands of narrow rings and gaps, all made of billions of ice particles. The size of the particles varies greatly, from dust grains to house-sized chunks. The rings are very wide, approximately 280,000 kilometers in diameter, but very thin. Thickness is only 10 to 100 meters, as wide as a football stadium but as thin as paper. An incredible ratio. Ring divisions. The main rings are named alphabetically, but not in order of discovery. D ring, the innermost, very faint, almost invisible. C ring, also known as the creep ring, semi-transparent. B ring, the brightest and densest ring, contains the most ice. Cassini division, a large gap between the B and A rings, 4,800 kilometers wide, formed by the gravitational influence of Saturn's moon Mimas. A ring, the second brightest ring, contains thinner gaps inside, the Encke gap, the Keeler gap. F ring, thin and twisted, shepherded by 2 small moons. G and E rings are very outer rings, very faint,
made of microscopic particles. Origin of the rings. How did the rings form? There's no definite answer, but there are theories. Perhaps an old satellite broke apart. It got too close to Saturn. Tidal forces tore it apart. Perhaps a comet or asteroid hit one of Saturn's moons. The fragments formed rings. Recent research shows the rings may be relatively young, perhaps only 100 to 200 million years old. They may have formed during the time of dinosaurs. And the rings are slowly disappearing. Ice particles are raining down onto Saturn, called ring rain. Perhaps in 100 million years, the rings will be gone. Atmosphere and storms. Saturn's atmosphere is also divided into bands like Jupiter's, but the colors are paler. Clouds are made of ammonia crystals. Below are layers of water clouds. Winds are very fast. At the equator, they reach 1,800 kilometers per hour, faster than Jupiter's. Occasionally, giant storms form, white spots. In the northern hemisphere, in winter season, there's a large hexagonal storm system. This hexagon is 30,000 kilometers in diameter, larger than Earth. Each side is straight, perfect geometry. How it forms is not fully known. Magnetic field. Saturn has a strong magnetic field, weaker than Jupiter's, but 578 times stronger than Earth's. The magnetosphere interacts with the rings. Charged particles hit the rings. Interesting plasma phenomena occur. At the poles, there are auroras, not as bright as Jupiter's, but still impressive. Satellites, many moons. Saturn has 146 known satellites. Most are very small, but some are large and interesting. Titan, Saturn's largest satellite. Diameter 5,150 kilometers. The second largest satellite in the solar system. Titan is very special. It has a dense atmosphere, mostly nitrogen, just like Earth. On the surface are liquid methane lakes. Methane rivers flow. Methane rain falls. But it's very cold, -179 degrees. Complex organic chemistry occurs on Titan. Precursor substances of life can form. Maybe there are primitive life forms. The Cassini mission sent the Huygens probe to Titan. In 2005, it landed on the surface of Titan. For the first time, a landing was made on an outer planet satellite. Enceladus is a small but active satellite, diameter only 504 kilometers. Water vapor erupts from Enceladus's south pole, icy geysers shooting into space. This water comes from a subsurface ocean. Beneath the ice shell, a liquid water sea. Cassini passed through these geysers, analyzed water drops, found organic molecules, chemicals necessary for life. Mimas is the Death Star moon. It has a large crater covering 1/3 of the surface. It looks like the Death Star from Star Wars. Iapetus is the two-faced moon. One half is bright white, the other half is dark black, a two-colored moon. Rhea has an ice shell. Craters may have a thin atmosphere.
Name and mythology. Saturn bears the name of the Roman god of time and agriculture. In Greek mythology, Kronos. Kronos, god of time, the god who devoured his children, eventually overthrown by his son, Zeus, Jupiter. Saturn's satellites take their names from titans and giants, the first generation of gods in Greek mythology. Discovery history. Saturn has been known since ancient times, visible to the naked eye. Galileo looked with a telescope in 1610, but couldn't see the rings clearly. He said it was an eared planet. It appeared to have two side protrusions. Christian Huygens looked with a better telescope in 1655. He correctly understood the rings. He also discovered Titan. Modern exploration came with spacecraft. Pioneer 11 first close flyby in 1979. Voyager 1 and 2 studied the Saturn system in 1980 and 1981.
Rings were seen in detail. New satellites were discovered. The Cassini-Huygens mission operated in the Saturn system from 2004 to 2017, 13 years, tremendous discoveries. Enceladus's geysers, Titan's lakes, ring details. In 2017, with fuel running out, Cassini plunged into Saturn's atmosphere, its mission completed. Saturn and human imagination. Saturn is seen as the most beautiful planet, the rings unique, poetic. Science fiction writers frequently use Saturn. Journeys between the rings, Titan colonies, life in Enceladus's oceans. Perhaps one day, humans will visit the Saturn system, build bases on Titan, investigate Enceladus's waters. For now, we can only imagine and observe with telescopes, with spacecraft. Uranus. General introduction. The seventh planet, the tilted giant, Uranus. Uranus is the third largest planet in the solar system. Its diameter is 50,724 kilometers, 4 times the size of Earth. It's classified as an ice giant, not a gas giant like Jupiter and Saturn, an ice giant. Tilted axis, the sideways planet. The most interesting feature of Uranus is its axial tilt. Most planets rotate upright or slightly tilted, but Uranus rotates almost lying on its side. Axial tilt is 98 degrees. This means as Uranus orbits the Sun, sometimes its north pole faces the Sun, sometimes its south pole, sometimes its side. The result is extreme seasons. One pole sees continuous sunlight for 42 years. The other pole remains in darkness for 42 years. Uranus's year is 84 Earth years, so seasons last decades. Where does this strange tilt come from? Scientists think in the early period of Uranus's formation, there was a giant impact. An Earth-sized object collided, knocked the planet on its side. Atmosphere and appearance. Uranus's atmosphere is mostly hydrogen and helium, but there's also methane, 2 to 3% methane. Methane absorbs red light, reflects blue and green light. That's why Uranus is light blue-green in color, calm, pale color. There are very few clouds. Uranus appears smoother compared to other giant planets. Bands are very faint. Storms are rare. But sometimes small white clouds are seen, methane cloud tops. They form in the upper layers of the atmosphere. Internal structure. The interior of Uranus consists of layers. Below the atmosphere, a hot and dense fluid layer, water, methane, ammonia ice, called the icy mantle, but hot, thousands of degrees. Within these fluids, perhaps oppositely charged particles, diamond rain. Carbon atoms can form diamond crystals under pressure. Deeper still, a small solid core, rocks and metals, slightly larger than Earth. Magnetic field, strange structure. Uranus has a magnetic field, but very strange. In most planets, the magnetic field emanates from the center and aligns with the rotation axis, but not on Uranus. Uranus's magnetic field emanates not from the center, but from about 1/3 of the way out and makes a 59-degree angle with the axis. The result, a very irregular magnetosphere, like wind-blown, constantly changing, chaotic. The reason for this strange structure is not fully known, perhaps related to internal structure. Perhaps the movements of the icy mantle are influential. Rings, thin and dark. Uranus also has rings, but very different. Saturn's rings are bright and icy. Uranus's are dark and rocky, almost black. There are 13 known rings, very thin. Even the widest is only a few kilometers. The rings contain organic matter. Perhaps radiation darkened this matter, like charcoal structure.
They were discovered in 1977 when Uranus passed in front of a star. The starlight flickered. The rings revealed their presence this way. Satellites, Miranda and others. Uranus has 27 known satellites. The 5 largest are Titania, the largest, diameter 1,578 kilometers. Icy surface, craters, cliffs. Oberon, second largest, diameter 1,523 kilometers. Surface covered with dark spots. Umbriel, third, diameter 1,169 kilometers. The darkest satellite, low reflectivity. Ariel, fourth, diameter 1,158 kilometers. Young surface, valleys, tectonic activity. Miranda, fifth and most interesting, diameter only 472 kilometers, but its surface is very strange. Miranda's surface is like pieces put together, different regions, different structures. There are giant cliffs, Verona Rupes, 20 kilometers high, 10 times Earth's highest cliff. Scientists think Miranda may have broken apart and reassembled, post-impact reformation. Name and mythology. Uranus, unlike other planets, bears not a Roman god's name, but a Greek god's name. Uranus, god of the sky, one of the first gods, husband of Earth, Gaia. Uranus's satellites take their names from works by Shakespeare and Alexander Pope, the only such planetary system. Titania and Oberon from A Midnight Summer's Dream, Miranda from The Tempest, Ariel also from The Tempest. Discovery. Uranus was discovered by William Herschel in 1781, the first planet discovered with a telescope. Herschel initially thought it was a comet, but they calculated its orbit. It was understood to be a planet. Modern exploration. Only one spacecraft has visited Uranus, Voyager 2. In 1986, Voyager 2 flew past Uranus, the first and last close flyby. Rings were seen in detail. Satellites were discovered. Magnetic field was measured. Since then, no spacecraft has gone. Uranus still keeps its mystery. Neptune. General introduction. The 8th planet, the outermost, the windiest, Neptune. Neptune is the 4th largest planet in the solar system. Its diameter is 49,244 kilometers, slightly smaller than Uranus, but denser. Neptune is also an ice giant. Its structure is similar to Uranus. Discovery. The planet found by mathematics. Uranus's orbit was different from what was calculated. Something was pulling it. There must be another planet. Mathematicians calculated the location of this unknown planet, Urbain Le Verrier and John Couch Adams, independently of each other. In 1846, Johann Galle pointed his telescope at the coordinates Le Verrier gave him, and there, a blue dot, Neptune, was found. For the first time, mathematics discovered a new celestial body.
Atmosphere. Deep blue in color. Darker than Uranus. Richer blue. Why? Methane again. But Neptune has more high-altitude clouds. It reflects light differently. The atmosphere is mostly hydrogen and helium. Methane is 2%, but it has a big effect on color. Storms. Great dark spot. Neptune has a very active atmosphere. Giant storms, rapid changes. In 1989, Voyager 2 saw a giant storm called the Great Dark Spot, like Jupiter's Great Red Spot, but dark blue. An Earth-sized storm. Wind speed 2,400 kilometers per hour, the fastest winds in the solar system. But in 1994, when the Hubble telescope looked, the storm had disappeared. It was very short-lived. Then other dark spots were seen. Storms on Neptune come, intensify, disappear, a dynamic atmosphere. Internal structure. Neptune's interior is similar to Uranus. Below the atmosphere, hot fluid mantle,
water, ammonia, methane ices, but liquid at high pressure. Deeper still, a solid core, rocks and metals, slightly larger than Earth. Neptune radiates more heat than it receives. It emits 2.6 times the energy it receives from the Sun. Where does this excess energy come from? From internal heat. The planet is still losing heat left over from its formation, slowly cooling. Magnetic field. Neptune's magnetic field is also strange like Uranus's, offset from the center, not aligned with the axis, tilted at 47 degrees. Magnetosphere is complex, irregular, constantly changing. This similarity shows that Neptune and Uranus have similar internal structures. Rings, twisted and thin. Neptune also has rings, 5 main rings. The outermost ring, the Adam's ring, it has an interesting feature. It's not homogeneous. Some parts called arcs, denser sections. These arcs form due to the gravitational influence of Neptune's moon, Galatea. The rings are dark-colored, organic materials, like Uranus's rings. Satellites, Triton and others. Neptune has 16 known satellites, the largest and most interesting, Triton. Diameter 2,706 kilometers, accounts for more than 99.5% of Neptune's satellite mass by itself. Triton is very special. It orbits in a retrograde orbit, that is, opposite to Neptune's rotation direction. This shows that Triton is actually a captured Kuiper Belt object. It was originally independent. Neptune captured it. Triton's surface is one of the coldest surfaces in the solar system, -235 degrees, covered with nitrogen ice, methane ice, water ice. But it's active. There are cryovolcanoes, not liquid lava, liquid nitrogen and water erupt. There are also geysers, nitrogen geysers. They shoot 8 kilometers high. Triton is slowly approaching Neptune. Its orbit is decaying. In about 3.6 billion years, it will get very close to Neptune. Tidal forces will tear it apart. A new ring system will form.
Name and mythology. Neptune bears the name of the Roman god of the sea. In Greek mythology, Poseidon, god of seas and oceans, god of storms, an appropriate name because of its blue color. Neptune's satellites take their names from sea gods and nymphs. Triton, son of Poseidon, half human, half fish. Discovery. Neptune is not visible to the naked eye. Too far, too faint. In 1989, Voyager 2 visited Neptune, the only spacecraft, the only close flyby in history. Voyager 2 gathered tremendous information: storms, rings, satellites, magnetic field. Since then, only observed with telescopes: Hubble, Keck, James Webb. In the future, perhaps a new mission, but it's very far, very expensive, no definite plan yet. Conclusion and closing. Comparing the planets. Now, we visited 8 planets, each different, each special. Inner planets, small and rocky: Mercury, Venus, Earth, Mars. Outer planets, giant and gas ice giants: Jupiter, Saturn, Uranus, Neptune. Between them, the asteroid belt, millions of rock fragments, a planet that never formed. Beyond Neptune, the Kuiper Belt, icy objects. Pluto is there too, now a dwarf planet. Evolution of the solar system. Our solar system is 4.6 billion years old. It formed from a cloud of gas and dust. At the center, the sun condensed. Around it, the materials of planets gathered. Inner regions were hot. Only rocks and metals could condense. Inner planets formed. Outer regions were cold. Ices could also condense. More material, larger planets, gas giants formed. And the system is still evolving. Orbits are slowly changing. Collisions happen. Change continues. Search for life. In the solar system, the only life we know of is on Earth. But perhaps there is elsewhere. In Mars's icy soil, in Europa's oceans, in Enceladus's geysers, in Titan's organic seas. The search continues. We're sending spacecraft, collecting samples, analyzing. Perhaps one day we'll say, we are not alone. Future explorations. In the future, more missions. Humans will go to Mars. We'll drill through Europa's ice. We'll dive into Titan's lakes. Perhaps a new spacecraft to Uranus. Perhaps to Neptune. Technology is advancing. Possibilities are increasing. Curiosity never ends. Our solar system is still full of secrets. Every discovery brings new questions. Final words. Tonight, we visited 8 planets. We listened to each of their stories, from hot Mercury to ice giant Neptune, all orbiting the sun, a cosmic dance. And we, on this small blue planet, watching them, wondering, admiring. Perhaps now your eyes are closed. Perhaps you're about to fall asleep. Good. Let your mind wander. Travel among the planets. Glide through the rings. Walk on the satellites. Sweet dreams and good night.